and how what a context graph is and how it can help. So I put together this slide here to talk about the three main components of what a context graph is. First, we want to capture metadata from all of the organization's existing data repositories, warehouses, or data catalogs, because most organizations will have multiple of these. So there's metadata is being captured, but it's all over the place. We need to kind of bring it together. The other thing we want to do is capture the transformation logs or the ETL pipelines that transform this data and move it from one place to another, because that is going to provide us a great deal of information about data lineage. It's also going to help us understand how when that data was last transformed, how fresh it is. And lastly, we need a central place to store all this data. So this is where the graph database comes in. We want to take all of these different moving parts and put them into a graph. And I think it makes sense for us to describe what a graph is for our audience. Mm-hmm. And so I kind of put this slide together. A graph database is different in that it stores its data in what is called nodes and edges. So those are the circles and the lines that intersect them. By storing data in this way, relationships and traversals like pathfinding become much easier. And this fits environments that are better suited for where there's a kind of many-to-many condition, right? In our mind, the graph is perfect for a context graph because of these different scenarios. Now, on the right is what's called an entity relationship diagram, and this is a depiction of a relational database, and this is what most organizations use and are very familiar with. They store data in tables, and those tables are kind of joined together at query time. That's kind of when you create the relationships, so to speak, between the tables. And this structure is, a lot of people are familiar with, but it tends to be very rigid and requires a lot of upfront engineering time. You have to kind of define primary keys and foreign keys and all that. And just moving forward to develop a context graph, you really kind of want to lean more towards the graph and its flexibility than trying to develop this with traditional methods.
And then the other takeaway is that with the relational model, it's very easy to see a relationship between one entity and another, but it's much harder to see the relationship between that n+1 entity. So that traversing the model so that you can understand the relationship between an entity that's over here with another entity that is quite distant is very difficult with a relational model. And that's where a graph database comes in, so that you can spot those relationships in a way that really with a relational model are very difficult, are not impossible, but very difficult to do, particularly at the speed with which businesses operate. So a graph database enables you to understand that relationships basically in real time and pursue lines of thinking that it would be almost impossible to do at scale with a relational model.
Right on. And you kind of teed up this next slide for us, which is what the graph metadata or data model would look like once implemented. So here you have the different nodes. Each are categorized based on the different data elements we capture in the graph. So for example, at the middle, you have a data table, and the table has properties. And a table might have a steward or an owner, and it might belong to a data repository like a database. And these objects here and these relationships will normally come from metadata captured in a data lake or a data catalog. And you would understand by looking at the data in a graph to understand that this this data table has a relationship with this repository, has a relationship with this owner, and this table has these properties, right? What we add with the context graph is context around that. So that's just kind of raw metadata, but we want to enrich that information with information from our transformation pipelines and information from our data consumers so that we can determine who's using this data asset, how often are they using it, and what's happened to that data asset.